You're famed for your choice of C. elegans as a model organism, and I know you've written about that too. What were you not so much, what were you looking for in an organism, an experimental organism, that led you to C. elegans?
The first thing we were looking for is to solve a finite problem. What we knew from the old literature is that the number of cells in these nematodes was quite small. That meant that if we were going to do things, we want to know everything, you see. Now, as you know, Isaiah Berlin wrote a thing called The Hedgehog and the Fox. And roughly speaking, you know, the hedgehog knows a lot about one thing, and the fox knows a little about everything in the old fable. But I decided the organism I wanted to be is the octopus, which has to know everything about everything. But in fact, it becomes very important if you're tackling a next level of complexity. Once we got away from single-celled organisms, we had to face the challenge of taking something which starts as one cell, develops a whole lot of different cells, and which is the essence of what we need to explain at this level. And therefore, we need something that we can accomplish a finite thing. So, for example, by sitting down and spending 20 years and working out the wiring diagram, how all the neurons are connected in this animal, what we wanted to do is to be able to say, if we had a theory to say, well, you see these neurons, this is the way this works. I always imagine the skeptic who says, how do you know there isn't another neuron, you know, that goes down the back of the body, through the big toe, comes up the front again, and that's doing everything. So to answer him, you have to say, there are no more wires. We know all the wires. How do genes control the construction of cellular machines that generate behavior? In other words, we want to know, how do you build a neuronal network? And the second thing is, how do these generate the actual behavior, which is at the next level? And what are the problems about that? And we knew that there was a midpoint here that we had to get strict descriptive information. And that was the structure of the nervous system.